look like. Jim Semino comes to us currently from Alabama. You see his title right up here. And prior to that, he was at the NIH, and having solved all of NIH's problems and having won an award for his VITRIS system, which stands for, I looked this up, Biomedical Translational Research Information System. He decided that that's it, the NIH's problems are solved, we're going south.
That's right.
And plus it's warmer. Prior to the NIH, he spent quite a few years at Columbia, where he was responsible for all sorts of things that U.S. students should know about, such as the vocabulary word in informatics, which is desiderata. How many people know what desiderata means? Excellent, just the faculty. That's great. Things that are desirable. You should read the paper. How did you pass Foundations 1? Also, speaking of Foundations 1, if you look at the cover of the book that we have used for years, you might see his name there as well. So I could go on and on and on, but Jim Semino.
Okay, thanks. Thanks for this opportunity to come talk to you. I hope you all signed the consent form, because this is going to be a little bit of an experiment. I'm experimenting on telling you my vision for electronic health records. So there's almost no substance to this talk. It's all speculation. Yes, did you have a question? Oh, she's just stretching. Okay. Thought it was early, but I'll call on you later. Okay. So how do we fix the electronic health record? And I had a lovely dinner with Elmer and Todd, yeah, thank you, Todd, and Funda last night, and they gave me all kinds of ideas, so I was up this morning adding things. So one of the things that occurred to me is the title of this talk is a little ambiguous. How do we fix the EHR? Some people may be thinking it's something like this. Okay, so if you, but that's not what this is about. So just to give you an overview, a little roadmap of what I'm going to talk about, I'll review, what is it, I just sort of laid common groundwork for electronic health records. Not all of you are clinical. What is it that we need or want from an electronic health record in the first place? If we think it's broken, what are our expectations? Then what's wrong with it that we're not meeting those expectations? And then I have a proposal for how we change the electronic health record, how I think it needs to evolve, and then a roadmap, a practical roadmap, I think, for making that change. Okay, so why do we want an electronic health record? Well, patient care, right? So we have patients that come into a health system, they are sick, or they need health maintenance, or there's some health issue that we're trying to monitor and take care of, and so we have a record of what's going on with the patient so that every time they come in, we don't start all over from scratch. We have what happened last time, what's happened in the interim, and so on. Then we also use them for health systems operations. So we need to know how many Band-Aids do we have to buy, how many nurses do we need to work in the ICU because of the patient mix, and that sort of thing. So there's all sorts of health operations. And then, of course, there's billing, which in fact is the main reason that we have computers in hospitals in the first place, is for billing. Now, that's where it started, because it was easy to justify buying a computer that was going to help you collect money. Because you'd say, well, without the computer, we'll get this many $1 million, and with the computer, we'll get this many more $1 million, and so it's actually cost effective. So that was very easy to show. Cost effective is healthcare, harder to show. And so billing was the first thing. And then research. So we talk about using the data that we collect in health systems for carrying out research, whether it's to support research to find patients that we could recruit, or it's actually to use the data themselves to look for patterns and so on. So those are some. Anybody, other uses of EHR data? Anything I left off? Legal. Yeah. So the legal. Defending yourself in court. There's and there's compliance issues. So there's a lot of sort of legal. The whole legal things. Health. The Joint Commission comes in and wants to see how you're recording data. If you want to be accredited, you've got to have you've got to have documentation of that. So all the legal aspects. Other ones,
Public health.
Public health. So yes, okay, thanks. So I'm going to start writing this stuff down for the next time. See, I told you this was an experiment. So good. Public health. What else?
Filling knowledge gaps.
Sorry?
Filling in knowledge.
Filling knowledge gap. What kind of knowledge gaps?
Clinical reasoning.
Clinical reasoning. Yeah. So I would lump that under research. So that would be one of the kinds of research we do. So outcomes and research, for instance, to say what's working. Right. Mm-hmm. Okay. All right. Good. All right, so what's wrong with it? So there's too much narrative data. We've got a lot of stuff in there that's just narrative. It's not in a structured, controlled form that's easy to work with, at least for computers. So a human can read it, and we at least solved the legibility problem by having electronic health records, but it's not as accessible for the kinds of things we want to do when it's in narrative form. We can use natural language processing, and then we have to show that it's accurate and effective. We also don't have enough narrative data. So we're missing a lot of data about patients. We don't fill in the whole story. And I just, as an example, my mom is 85. She's the youngest of 13 children. She's the only one living now. And we had this lovely conversation about how all of her siblings died. And she commented that 2 of her siblings had died of pancreatic cancer. And they were also the only 2 siblings in the family that had red hair. And didn't I think that was interesting? And I thought, well, that is interesting. And it's also a little depressing because in my 30-some-odd years of writing electronic medical records, I don't think I've ever recorded somebody's hair color. So if I wanted to go and say, does hair color correlate with pancreatic cancer, I probably wouldn't be able to figure that out. So we're missing a lot of data that people don't fill in because they're too busy. Well, where's the chest pain? And when did the shortness of breath start? And why are you bleeding like that? I mean, we put stuff in there and then we miss a lot of the other detail that's relevant to the patient's overall health, but maybe not relevant at the moment of care. And so we're missing a lot of these details of things that, sort of the level of detail of we record patients having pain, but do we record it on a scale of 1 to 10, or do we just say the patient's having pain, and today the patient says the pain is better? Wouldn't it be nice to know the pain was a 2 yesterday and a 1 today, or a 10 yesterday and a 5 today, to really be able to quantify some of that? And then there are all kinds of chronological gaps. So patients go home, and now they're home, and they're having health issues at home, but nobody's recording those. When a patient gets sent home, it would be nice to know how many days were you out of work after you left the hospital. It would be nice to know that, because if we're sending people home too early, maybe we find out if we keep them in an extra day, they go back to work 2 days sooner than if we send them home too early. Then they sit at home longer than they would otherwise. And of course, people go to other health systems and get their care in a fractured way, a fragmented way. So how did we end up here? How did we end up with the health records that we have today? And it's always good to kind of look at the history because that kind of shows you how you got where you are. I think that if we were in an alternate universe, or maybe in a developing nation where there may be no records at all, patient comes in and says, here I am, okay, what's wrong, how long you had this, what did they do last time, and it's all, every encounter is a new encounter, and you go in that setting or in an alternate universe where they don't have any health records at all and say, hey, we've got a computer, let's create a computer program to help me take care of these patients. The thing we would develop would be very different than what we have today. So what we have today has evolved from where we came from. So where did we come from? So this is a quote from Florence Nightingale, who started the International Red Cross, among other things, in attempting, she was a nurse, International Red Cross, is that? No.
No,
So,
that was Clara Barton.
That was Clara Barton. She was American Red Cross.
No, she was actually the one that was the statistician that was in England that started nursing in the Crimean War.
Oh, okay. So, in any case, she was looking for records. She was actually looking for them for financial reasons, because if she could show that people were taking good care of patients, she could get charities to contribute money to caring for patients. So this is 1863, so 150 years ago, and people were looking for health records. And I always reference Octo Barnett's paper from 1993, where he pointed out this quote, because I hadn't read this initially. Okay, so a national solution. We now have national efforts to create health records. So this is a quote about establishing a committee that would help guide the federal government, the U.S. federal government, to create health records for the whole nation. And that was the President's Science Advisory Committee Life Sciences Panel. Anybody want to guess what president?
Bush.
Which Bush? No, there wasn't the other one either. Just the Americans, I guess. Okay, it's a little further back.
Oh, wow.
Close, Kennedy. So 1963, and now 50 years later, so we finally have the Office of the National Coordinator that's pushing us. But so we've been asking for this for a long time, but it's been hard to get there. All right, this article is more important than the Desiderata paper.
No.
Yes, and I recommend that you go and try and go and find this and read it. It's actually it was broken up into 2 pieces. New England Journal of Medicine, 1968.
Three articles.
Really? Oh, okay. All right. Read all three then. So actually, Larry Weed and I had a big argument over terminology, and it actually was here in Houston at NASA. We were consulting for NASA together. So Larry Weed is grandfather of informatics, although maybe he wasn't thinking of it that way at the time. But Larry Weed was looking at medical records and saying, these medical records are horrible. We can't tell anything from them. Let's try and create a different organization of them. And this is a typical record. This was taken from the paper. And you can see it's a little diary of what happened. The patient received some insulin, and it was febrile, had a fever, he coughed up something disgusting while you're eating lunch, and and then some other things happen. Don't read this while you're eating lunch. So, all right, so there's Larry Weed giving a talk at Baylor University. This is a little later, 1970s, and you can find this on YouTube. Go look up Larry Weed and Baylor, and you'll find this video, and it's about an hour and a half. You don't have to watch the whole thing, but it's worth watching part of it to see his style and how he's berating everybody. He sounds really friendly, but he's actually berating everybody for doing a lousy job of record keeping. And what did he want? He wanted records that looked like this, where there were enumerated named problems, and there was an impression for each problem. What do you think's going on with this problem? Because when he reads the record, you'll see he pops in there and he's like, well, why was the patient on this drug? Was that for blood pressure? You don't use this for blood pressure. You must have had something else going on. Now they're doing an x-ray. What's the x-ray for? Did the patient fall out of bed? Well, it doesn't say. So he goes through that, just reading these records and embarrassing the house staff at Baylor. So here is, so he's got this problem list, and then he's got plans. And the plans are enumerated also to match up with the problem, so that you can see from the record not only what happened, but what's the thinking of the clinician. And he actually, in these articles, in 1968, talks about computers quite a bit. Mentions the things that computers can do, and there's a lot of other futuristic stuff in there, like, for instance, maybe physicians shouldn't be doing physical exams and taking histories. Maybe we should hire people that are specialists in that, and the physician should be reading the information and doing their clinical reasoning. So really, really interesting papers. Well, we haven't, structurally we've gotten to this point. So when you use an electronic health record, it asks you, okay, what are the problems, and you can enumerate them, but it's not represented in a way the computer really helps you. It just says, okay, fill in some text, and maybe there's a controlled term. It says, okay, what disease do you want to put in here? All right, put rheumatoid arthritis, then you type in whatever the heck you want. And the computer just says, okay, and then if somebody wants to see it, it shows it to you. So it's still just a big diary. All right, and these are the paper records. This is 1968. There were no commercial electronic health record systems. The first commercial health record systems, kind of mid-70s, a little bit. We had one at NIH in 1976 that was actually commercial. But really, everything was pretty much paper back then. And so what happened? So we started building electronic health records. So when they built the first cars, they looked around and said, what should a car look like? They didn't have Back to the Future movies or anything. So they just said, we don't know what a car should look like, but it's kind of like a carriage, only no horses. So let's build a horseless carriage. So this is an early automobile, and you could imagine a horse being hooked up to the front of it, and so that was the design. And then you had to start someplace, and then you want to say, well, okay, what's wrong with this? Let's make it fancier. Let's do a better job. That's what we did with electronic health records. So the first records are kind of horseless carriages. And then you start to realize, okay, we need to make this better because, we're competing. We want to sell a better one. So what do? You build a better horseless carriage, all right? And so you just keep building on the same model as you go along. And, the CAT scan, I had a patient who had a CAT scan once, and he didn't fit in the machine. He was too big to fit in the machine. And I happened to be at a conference where the inventor of the body CAT scan was giving a talk, and at the end I ran up and I said, how did you decide how big to make the machine? And he said, well, we had to start someplace, so we just went out in the hallway and measured a bunch of people and figured out that's how it should be. And I said, well, that was the first one. How come the ones today, the commercial ones, are the same size? He said, because they didn't want to try to redo all the calculations. They just used my calculations and built it, and you couldn't change the size. It was tied to the calculation. So, we have these fancier horseless carriages, and if you go to an electronic health record today, what you see is a diary with a bunch of other things slapped onto it. So it's like, oh, we better do medication reconciliation. Let's add a piece. Oh, we're going to do decision support. Let's add a piece. And they add all these pieces that need other data that require the physicians and the nurses and others to add additional data, redundant data, without really adding to the richness of the data. And it's sort of a natural evolution. So that's kind of what's wrong with it. So what do we want to do with it? What do we really want to do? Let's think of, if we think about some specific questions we might ask of the record. I think that's a nice way to think about it, because then we can kind of take those questions and reverse engineer what the record should do. So, for instance, what are the patient's acute problems? Well, there's a problem list, but when you look at it, you can't tell whether it's an acute problem, a chronic problem. So a patient comes in and it'll say myocardial infarction, poison ivy. Which one's most important? Well, you think myocardial infarction, right? No. What if the myocardial infarction was 6 months ago and the poison ivy is so severe the patient needs IV steroids to control his discomfort? Then maybe that's more important. But the fact that he had a myocardial infarction, is that relevant or not? It depends on how recent was the MI, because giving steroids to somebody who just had an MI is not such a great idea. So the computer has no idea. The medical record has no idea. It just says, here's all the problems, and you go and look at them and try and figure them out. And one of my students and I like to tell stories. It fills in my lack of knowledge. I had an informatics student, Ching Zhang, who's now on faculty. I think she's moving to George Washington University in DC. I took her on rounds with me. I was attending on the wards, and I went to see this patient, elderly guy, like 90 years old, and he'd had a stroke, he had some dementia, it said, and he was in for pneumonia. So I go see the guy, and he's laying in bed, and I'm trying to talk to him, and he says, and he's not really talking. And I'm reading the record, and I'm trying to figure out, is this baseline? And it says stroke, and I can see he's got a weakness, and and I'm trying to figure out, is this new, and what's going on? And he doesn't have a fever, and I asked the nurses, and the nurses don't seem concerned. They said, yeah, that's how he was when we got him. I'm like, okay. So then we go back the next day. It was a weekend, so that was Saturday. I go back Sunday. The guy is sitting up, eating his breakfast, reading the New York Times. All right, so clearly, there was something happened on Saturday that I was unaware of this, because the record didn't help me understand what his. I don't know. Yeah, he was reading the Washington Post, the Daily News on Saturday, and he was a Daily News person on Saturday. And anyway, had it been reversed, had he been doing that on Saturday, and then I came to see him, he would have gotten a big workup. He might have got a spinal tap. He would have gotten a CAT scan. It was probably medications that he's an elderly guy, and they probably over-medicated him for sleep or something. But it was a little disturbing to think that the medical record didn't tell me enough to understand what was going on with that patient.
That's a really common thing.
It is too common. So what does the physician think is going on? So we have these impressions, and that's in there, but it's not in there in the way the computer can understand and help us. So the computer can't say, oh, you're thinking about this, let me get some information for you to help you. Also, what are the patient's preferences? What does the patient think are the biggest problems? Why is the patient here? Does the patient want this problem fixed, or does the patient want their life extended, or are they sort of, are they looking for palliative care? The computer has no idea. So it's going to recommend things based on the average patient, not based on the patient's preferences. And so we have a number of options that we can do, but we want to go and find the current best evidence, not what I learned in medical school, not what I learned the last time I studied for the national boards or the last time I read a journal, but what is it today that's the best evidence-supported approach for the patient? The computer, we'd like the computer to be able to help us with that. Seems like a reasonable thing. What about genetic influence, personalized medicine, and all this? So what genetic makeup does the patient have that may influence the choices we make? Don't give him that drug, it'll kill him because he's got this variant. Or don't give him that drug, it's not going to work because the bacteria he has have this variant, or whatever it is. So we want to be able to bring that information to bear. And where is the patient in the process? The patient comes in, we admit the patient, we write a bunch of orders, and now there's a guideline somewhere. I've got it on paper, and I'm following a guideline. Maybe it's in a computer. The computer has no idea where the patient is in that sequence. So we can't say, oh, today we're supposed to do this. And if we pass that point, it doesn't say, gee, he's on this guideline. He was supposed to get a CAT scan yesterday, so you better get the CAT scan today because you're going to miss that milestone. So where is the patient in that sequence? And what happens when the patient goes off track? We have a plan. We say, here's the best evidence for treatment. We're doing everything we're supposed to do. Patient starts going south anyway. That happens. We want to be able to detect that, first of all, and then we want to be able to say, okay, now what do we do? How do we get the patient back on track? What's the evidence for the next choice? So what do I do now? And then, oh yeah, there's also all those other secondary uses while we're at it. This is just the patient care stuff. And maybe we can do these other things too if we do all that stuff right. So those are just the questions. You could pick one of these and do your PhD on this, okay? Those of you that are PhD students. These are tough questions to answer to get. You can ask a human to do it. You can ask your intern to go off and do this stuff. But how do you get the computer with its vast memory and its attention to detail and the fact that it never falls asleep? How do you get it to do that kind of stuff for you? All right, so the EHR, we have to remember, is information. It's a shadow of reality. We've got our patient, and then we've got this shadow. And the shadows that we see in EHRs now are kind of like this, okay? A flat film, you put a radiation source, you put a film, you take a picture of a patient, and it's a shadow, all right? And then think about when we added computers to radiology. Now this is an MRI, or this is a CT scan. We have much more detail, much better ability to process these data and do things like feature detection and that sort of thing. So this is where we need to move our electronic health records from this shadow. Let's see, this is from that shadow to something that's more computable. Okay, so I have my genealogy. I made this up. I didn't make it up last night, but I've made it up recently. So first generation homegrown systems by informatics groups, okay, in Utah, in Indianapolis, in New York, in Vanderbilt, in Nashville. So all these places where there was an informatics group that said, we've got to build something that we were applying computers to patient care, and they took the patient record and they said, okay, how do we take that and make it better? People had ideas about things they could add to it, so we'd see decision support, we'd see better visualization, we'd see a lot of enhancements, very clever stuff, a lot of it, but it started there, and they have been gradually getting replaced until I think they're almost all gone. Now, they've been replaced by commercial systems. So there was an initial wave of commercialization. Companies would come and they would say, hey, we're going to work with an informatics group and build a system, or we're going to go off in a corner and build a product, and we're going to try to sell it. And there was a lot of that and a lot of thinning of the herd, and then some kind of hang in there, and then other companies came and bought them up and incorporated the code, 30-year-old code, into the products we have today. So the current generation is these mature commercial products that do a lot more than just be a diary for the patient. They're doing billing, and they're doing compliance, and they're doing a lot of other stuff. But in terms of the patient care process and the representation of patient information, really kind of the same thing we were doing 30, 40 years before. But these are a mature product, and that's kind of where we're at today, the third generation. So the fourth generation is the next one. What's coming next? And my hypothesis is that if we're going to improve healthcare with electronic health records, the next generation has to do two things. It has to model the state of the patient, and it has to model the strategies of the healthcare process. And I'll talk about that a bit and how we do that. So if those are computer science people, come on, I'm not going to call on you. Just raise your hand, computer science. All right, so 3 computer science people. Really, that's all you have? All right, finite state automaton. If you learned about this, you should have learned about this when you took computer science. You represent the state of some system. And it's got a lot, what's that?
You should have learned about this in many places.
That's right. So you have a state, it's got a lot of parameters, they have values, and you can move from one state to another with transformations. So if you say, well, I've got a patient state and the patient's potassium is 2. Well, I can move the patient to a better state by giving the patient potassium and raise his potassium. So that would be a state transition for a patient. It's hard to do that, and it's hard to model a patient completely. But I think we could model a lot about patients that once we started understanding what sort of priorities were for the patient care, what the strategy was, we could use these kind of states to build better systems. So that's the state representation. And then there's tactics versus strategy. So right now our system has tactics. Let me talk about the difference. People get confused about this sometimes, using interchangeably. So this is my son playing chess, this giant chessboard. And you think, by watching him move the pieces, that you know what he's doing. You think, oh, he's playing chess because he's moving this piece here and that piece there. And you don't know his overall strategy. You just see his tactics. You see one move at a time. And that's what we see when we look at an electronic health record. We see, here's the order, here's the impression. We see these little pieces, but we don't see the overall strategy. In my son's case, the strategy was world domination. Okay, so he was really actually trying to get, this was his goal state, but you couldn't tell that till he started to get there. But a strategy is sort of the overall plan for how you're applying those tactics. And electronic health records don't have a representation of strategy. Maybe we'd say it in our note, but we don't put it in a way the computer can go, oh, that's what you want to do. Let me help you with that. All right, so we can look at health records as sort of a cost benefit or efforts benefit balance. So there's a lot of efforts, and every time we want the computer to do something new, we create a new effort usually for some poor physician or nurse or allied health professional, somebody, not an administrator, but usually somebody that you're paying a fixed salary to, and you go, oh, now you have to do this extra thing on top of everything else you're already doing, so we can get a better benefit out of the system. So what do we have? We have writing notes. Very tedious process, and if we think about what writing notes, how do we do the note? We do this in medical school. I don't know how they do it in nursing school exactly, but it's probably similar. Okay, doc, you're going to be a doctor, you're going to take care of these patients, you're going to think, you're going to use hypothetical-deductive reasoning, you're going to do a great physical exam, you're going to take a great history, and you're going to plan, and you do this. Oh, and by the way, you have to write it all down in a note before you go home. All right, so now that's sort of a secondary thing. It's not seen as a primary thing. It's an extra thing on the side, writing that note. And then we came up with all the rules to limit the house staff, how much time the house staff can be in the hospital. So they've got to write it before they turn into pumpkins. And so now they're frantically writing the note. Or the attendings who are not under that constraint maybe go home and do it on the weekends. And they write their notes at night or in the weekends. And so, what do those notes look like? Are they complete? Are they carefully thought out? Do people forget things because they waited too long? It's not going to be ideal. So that's where we have today. There's order entry. So, we have a lot of work to do order entry, and that takes a lot of time. And mainly because we've replaced this sort of haphazard written approach where there's a lot of sort of generally, understood cultural things about when I write this order, this is what I really want to happen, and we all know that. Now I have to say it very explicitly for the computer, and it's time consuming. And then there's other data entry that we collect for various purposes. And then we have alerts, which is an effort because of the fatigue level that it introduces. So you get 100 alerts, and 90 of those you should ignore, okay, because they're foolish. And 10 of those you should pay attention to. But when you're looking at 100, you go, well, there's 5, I'm going to pay attention to those 5. And then the other ones, you're not seeing 100 at a time, you're seeing 1 at a time, and you're missing 5 of those because that other 90 has overwhelmed you, and you just ignore them. So we have alert fatigue, and we're ignoring half of the alerts we should be paying attention to because we have 99 times as many things that are just nonsense. Because the computer doesn't know everything that's going on with the patient. So it says, hey, don't give him this drug. He might have a bad reaction. I'm like, he's been on this drug for 20 years. I don't think he's going to have a bad reaction. But the computer maybe doesn't know that. All right, so where are the benefits? There are benefits. Results review. I can tell you, as somebody who went through his residency when we had paper records, you had to call the lab and wait on hold for the lab results. Result review was horrendous. And so now you can get it anywhere. You can get it from home. You can see all the results in one place. If somebody else has the chart, you can still see the results because it's not. We did great results review at Columbia. I don't know about here, but we did a great job. That's the low-hanging fruit. Well, now, what's that?
Wait till you get it.
So genetic data is sort of an effort right now because we're putting the genetic data in and trying to figure out how we're going to deal with this, how we're going to cope with this overwhelming amount of data. But the benefit is supposed to be personalized medicine, right? So that we can take genetic data and provide better advice because now we have this underlying genetics. This is just an example of a report. This is a tumor biopsy, and it's got some variants, a variant detected, and there's this variant, and it says in this tumor type there's FDA-approved therapies, and in another tumor type there's other FDA-approved therapies. So even though the patient has a different cancer than the one that's been studied, maybe because of the variant we can apply some other stuff. So this is not something you can learn this process in medical school. But you're not going to memorize all the variants. I mean, that would be, when I went, that's what they do. They say, okay, memorize all the variants and which drug works with which variant. Now, it's just impossible. Thank God we don't have to try to memorize it. We can go look it up somewhere, and it's changing every day, right? Every day, the FDA is approving new things. People are publishing new studies, so this changes all the time. What's next on my patient entered data? So the patients can contribute data to the record, too. We don't do a good job of that right now. We have patient portals, patients put things in, they send us notes, but we don't make a good use of those data. There's also social media data. I should add the word social media. It should be social media data. People are putting things in Twitter, they're putting it on Facebook, they're putting, I don't know where else they put it, but it turns out those data are actually relevant to their patient care, and if their doctors could see what they're saying, they're going on some message board and going, my diabetes is getting worse, I think, what should I do? And some other person on the board goes, well, you better eat garlic, or you better kill a chicken, or, do who knows what. And, it'd be nice as the physician to go, yeah, it's okay to kill a chicken, but you should also, call me or change your medicine. Or they may be giving him good recommendations to say, my doctor told me when that happened, I should do this. And the patient tries it and it works. Wouldn't it be nice to get that back to the physician? So finding ways to capture all that contextual data and get that back into the record so people could make use of it. So if we have more context information, then maybe we can get rid of some of these alerts that are unnecessary. We can have more accurate alerts because the system will know more about, it'll know the same stuff that the clinicians who's overriding the alert knows. So the common sense things, patient background, and other contextual information. And then we can use that context also to understand what information needs might be occurring at that moment for that clinician. And there's been some research in there. I've done some of that work in something called info buttons. So this is just a little summary from our electronic health record. And I actually, whoops, sorry, I pasted some info buttons in the slide just to show you what it looks like. But an info button would be something here that is relevant to the particular drug that it's next to, and it knows the patient's age and gender and that kind of stuff. And so when you click on it, it says, oh, you're a physician, the patient's this, and it has this underlying problem. You might want to go to clinicaltrials.gov, let's say, because your information need is, well, how do I get this patient into a research study? And it's not just clinicaltrials.gov, but it's searched for lisinopril and maybe put in the age and gender and other things to get you a more specific result. And you could put other things there as well too. If you study the information needs of people in clinical settings, you learn that they have very particular recurrent needs, and we can anticipate those and build links in. But we have to know the context to do that. We don't want to just say, here's 100 links you can go to. And then when you get there, good luck typing in, figuring out what terminology it uses and what the user interface is doing and so on. I mean, that can work to a certain extent, but people just pick the one resource they know. At Columbia, when we looked at resources, they were always going to Micromedics. Micromedics is a drug database, but they would go there to try to figure out what a disease was, because it would say, well, this disease caused by this thing, and then you go, oh, that's what it is, and they're using the wrong resource. But that was the one they were familiar with. So you can provide resources that they've never heard of if it's relevant to a particular information need, and it can be customized to get them in and get them the information they really need without having to learn a new interface or learn a new terminology. So this works now, but requires two things. Informatics study of the information needs, but also contextual information in the patient record that helps predict what the information need is. Okay. And so this is where I get the cheers from the clinical people. I want to do away with writing the notes. Okay, I want to say you don't have to write progress notes anymore, because if the system has enough information about the context of the patient and my thinking as a physician and the patient's thinking and priorities and preferences, we could generate the note automatically and get rid of note writing. And so when I tell that to the clinical audiences, they love the people in the white coats, they start applauding. It's like the Republican debate when you say you're going to shut down the EPA. They just start cheering irrationally, like, oh yes, who needs notes? Of course we need notes. What?
But how will we bill?
Oh no, that's the trick. My hypothesis is that we can generate notes that will be useful for the billing process. Very important. You can't keep the lights on if you can't do billing, and you can't do any patient care if they've shut you down. But I think we can do that, because certainly the notes that we can generate will be at least as complete as the notes that we have today. And then we can start looking at developing pathways that the patient can be on and track them through these pathways. And then we can do this research, and we talk about the learning health system, and the system that will take individual personal records, merge them into the electronic health record, merge them into patient groups through health information exchanges, and get national level information from sort of all the way through, and then we can develop clinical guidelines that go back and affect public policy and actually clinical decision support at an individual level, record the outcomes, and then use those outcomes then, quality measures, to figure out which ones worked and which ones didn't, and update our recommendations and so on. So that's the learning health system in a nutshell. It starts here. It starts with high quality individual data before you can do any of this other stuff. And this is just my research slide. This is I2B2, so a nice repository full of data that you could go in and query to answer your questions. Is there a clock? I have no idea what time it is. 25? Oh, I better slow down. Run out of slides. Okay, so I'll tell another story. That's why I always stall. So I had a lovely dinner at Informatics last night, and I got a chance to talk to the manager there, who was saying he was having trouble getting cooks to work there. And I thought, really, it seems like it shouldn't be a problem. He goes, well, the first cook I had was a vegan, and it didn't really work out because we have a lot of meat, and he didn't really get it. He goes, and then the second one was this guy from England who just doesn't get the idea of spices, and very important in America. So I don't know if you've eaten there. It's a wonderful place, just amazing dishes, but the cook just couldn't do it. I said, so is that it? He goes, no, we had a third cook who's an informatician. And I said, so what's the problem with the informatician? He goes, well, instead of cooking the meals, he kept coming out of the kitchen and telling the customers how great the food was going to be. All right. Nobody gets that joke. Okay. So we in informatics and computer science, we tend to sort of say, I can see how to do this better. And so we do a lot of, sort of predictions or speculation. Instead of actually doing it, we just talk about how great it's going to be. So this works everywhere else. I don't know why it doesn't work. Okay, so I have a proposal. This is all speculation now, but I've been doing this for 35 years. I've been working with building electronic health records, and I can kind of see a path forward. And that path forward, first of all, we have to represent richer information about the patient's state in a computable way. Something the computer isn't just recording and spitting back or doing natural language processing on, but actually knows, okay, the patient has this condition right now, and I know I can use that information to go run an algorithm, to do a literature search, to pull up a guideline, and so on. So information about the patient's state. We need to model the strategies. What is our goal? What are we trying to reach? How are we going to, what's our general approach to get there? The computer can provide the tactics once we go, look, this patient has cancer and pneumonia, and he can't breathe, and he's uncomfortable, and this guy, we're going to give him antibiotics because his cancer, he's got like a mole, and we're removing it, and it's not a big deal. And yes, he has cancer, but he's got a full life ahead of him. We're going to treat his pneumonia. Here's another patient where the patient doesn't want any unusual measures, so we're going to try some antibiotics, but we're not going to give an antibiotic that's going to make him feel worse, and we're going to try to give him something that helps his breathing that may actually shorten his life because it'll decrease his oxygen, his sense of oxygen deprivation, but it'll make him more comfortable. Those are two different, very different tactics. You have to know the strategy, the goal state for what you're trying to do. And we need more data. We need history data, family history data, travel information. We want to know, we want to know, where did this patient, was this patient just in Western Africa? Is this a place where we need to worry about, communicable diseases in that area? And patient's genetics. So there's a lot more data we have to get, and we have to fill in those gaps and get much more detailed data. We have to take advantage of what existing records do now. I'm not advocating ripping out the systems we have in place. They're too ingrained, and they do a lot of things that we need. We need compliance, we need billing, we need all these other legal things. What we want to do, though, is look at the clinical stuff that those systems, they don't really care what they're just like, yeah, here's a record, whatever. We don't care what it is, as long as we have the billing, as long as we have compliance, as long as here's a progress note that somebody wrote. We get the orders, we send them to the lab, we send them to the pharmacy. That's what they care about, but there's nothing that cares about the quality of the representation of the patient. That's the part we need to work on. So we don't want to disrupt the current EHR. We want to make these changes without disrupting what's there. Okay, so it's disruptive technology that's not disruptive. All right, so how do we do that? So there's I see a road forward that has 3 stages. So the first stage is the black box. Okay, so we have our electronic health record. We have this black box, and we have this electronic health record, and it's got its tables and data in there. And we've got this black box that has the information we need to do all the things that I'm talking about. Don't worry about what's in it or how it gets there. The first question is, how do we integrate that with the electronic health record? Well, we can actually just store it in there because this black box is just a document as far as the health record is concerned. And the health records are very good about storing documents. Oh, you have a scanned-in image of a pathology report from it? Fine, here's a place, we'll put it in there. So it'll store documents, and we want to do that. We want to take advantage of the EHR's ability to do that because it can store it, it keeps it safe, it's for a particular patient, it controls who gets access to that document. So there's a lot of things that it does that are very sort of, mundane technical things, and we want to take advantage of those. So we have our black box that is going to do all the things we want. All right. So how do we get that back in and out? There's this thing called Fast Health Interoperability Resources, FHIR. It's an HL7 standard that has been developed for sort of lowering the barrier to moving data in and out of commercial electronic health records. So you could use something like FHIR to go, here's a document on this patient. And the system, according to the Office of the National Coordinator, these systems are all going to be able to do this. You take the document and store it and go, great. And then if you want it back, let me know, and I'll give it back to you. And we never show that document to somebody in the actual EHR because it wouldn't be meaningful to them. It's a black box. So what's in the black box? Let's open it and look inside. What we put in there is something that is, you know how long it took to make that black box? So this is RDF. I don't know what it is. It's XML. It's a semantic representation of the patient. I don't know what it looks like yet. But if you give me one of those questions from my list, I could reverse engineer that. I could tell, oh, you know what, if we want to answer this, this is what's going to have to be in here, and here's how we're going to have to tag it so computer systems can make use of it. So I can generate this from a bunch of use cases. I can create that, Then I pop it in the black box and I store it in the EHR. And then whenever I need it, I pull it back out. Well, then what? Well, then I have applications, and we could use SMART, for instance. And SMART is Substitutable Medical Applications for Usable Technologies, kind of a contrived acronym. But the idea of SMART is that you could build apps that you could get on an app store to work on your electronic health record. And everything your health record doesn't do, your app could do. And they've been out there and they're fairly successful. And there are things like calculators and that sort of thing. What they don't do is actually write back into the electronic health record. But if we have something like this and these apps can modify this, so we say, oh, here's an app that's going to ask me what you want to do next, and now I put that in here, that can pop back in and we can store it. At least we can store it in there. We still can't act on it. We've got to pull it back out and give it to some other app that decides what to do about it. But at least we can break the problems down. My question list, we can break that down. Some of those apps will collect the data, some of those apps will use the data, but we can all sort of divvy this up and we can solve this problem. All right, so maybe we're getting there. All right, so we call that smart on fire. So people have coined this term, smart on fire, the combination of the external applications and the ability to communicate with the health record. Because there's other stuff I haven't drawn in here that smart or fire will also be able, I should add an arrow, fire can also get data from the EHR tables, so we don't have to put everything in here, we can also pull stuff from the EHR, like the lab results and that sort of thing. Okay, so the fig vine or fig tree starts out as a vine. The strangler fig looks like this. You plant it, it grows as a vine, and it grows around the tree, and it grows up and uses the tree for support. So this is my phase one. I'm using the electronic health record. The tree is my electronic health record, and I'm building this vine that kind of grows up alongside it and has a sort of life of its own. All right, so phase two, we now can say, all right, well, let's start to empower the electronic health record itself. We don't have to externalize everything. I mean, you've got the system there. It does a lot of stuff. It interacts with the clinicians. It can do some of the data collection. What if we start to empower that by making the data available to it? So instead of having a black box in there, I would break this down into what I've been calling the EAV plus table. So EAV is entity attribute value, and this is a model that people typically use when they don't know how to model the data, like I2B2. So it's not that they don't know. They know they're going to get lots of different kinds of data, and they want one thing that can hold everything. So you have a column that says, this is the column for the entity. What am I storing? A blood pressure. Okay, what's the attribute? Oh, it's the value. Okay, and then there's the value is whatever the value is. Another attribute might be the units of measure, and then I have what units of measure I'm putting in, millimeters of mercury, or whatever it is. So I break everything down, and I could break this thing down, and I'm sure I could store all these things as little facts in a big EAV, and I call it EAV plus because I like to add other things like patient identifier and a few other columns that make this a little bit more normalized, so it's not such a chore to get data out of. But the bottom line is I take that and I put my data in Smart on Fire, and I have somewhere I can have a translator that breaks it down, and then when I need that black box again, I can do the query and pull everything out and just create that standard view of the patient and send it back out to my applications. And then, once I've done that, I can make the EHR able to access that table a little bit. I can just say, so I go to the EHR folks and go, well, you know, you want to make your application a little better, there's these data here that we could use. And the example I use is Cerner, and I'm actually doing this with genomic markers for cancer care. We're breaking all those SNPs down into individual things that will go in a table, and then the EHR can read those. What's it going to do with it? Probably nothing directly, but we can create decision support that can get access to it. So for example, we're going to have a form, and you go to fill out the form when you're going to take care of a patient with cancer, and it will pull up not only the relevant variants that came into the pathology report, but it'll also go out to some external knowledge base and say, here's what you do about that variant. And what's different than what we do now is, right now we just have a PDF, has the variants, it has the recommendations, it's a fixed thing that goes in the record. Now, the recommendations don't have to be fixed in time. If the patient comes back a year later, we can go look up the variants and see what's the new recommendations, because those are dynamic, those are changing, and they're out in some external knowledge base. So we can actually start to enhance the decision support to use current knowledge that's be impossible to maintain in lots of little rules. Every time somebody publishes a paper or the FDA approves something, you go rewrite your rules. You put it in a knowledge base and let the decision support know how to query that and match it up with patient data. So we just do a little bit. The camel's nose in the tent. Okay, and so it's just a little bit of data, and if we just do this little trickle, then suddenly smart people will go, oh, hey, I can get more data and more data and more data, and it starts to evolve. So what happens to our strangler fig? Well, the fig, eventually the fig vines coalesce into a kind of a trunk around the tree, and eventually kills the tree, and replaces it. So the original tree, whatever it was, doesn't matter, it's dead, and now there's a fig tree that kind of stands on its own and drops seeds and that become vines and go and kill other trees. So this is sort of my evolution, or what I was thinking about. And then I learned a little factoid that I'll share in a minute that helped me come up with a healthier, more sort of positive metaphor than just the strangler. Because I was telling this to Cerner, and they're not happy. Oh, you're going to kill our product? And I don't think they really think I personally could kill their product, but they've made them nervous, I think. So, okay, so what's next? Symbiosis. All right, so the strangler fig, that's symbiosis too, but it's not. So commensalism is really what I want, is where they live together in harmony. Okay, so how does that work? All right, so what I'm anticipating, so there's my sort of state of the art. Watch what happens. Watch the EHR table, the EAV table, and the smart apps. They're all going to change. Okay, so the EAV table got smaller because now I start to put more data over here, and I don't have to rely on the EAV table so much. And the smart apps decrease too because now I can do more of the stuff in the EHR, and I don't have to have these external links. They didn't go away completely. Okay, we still have the mechanism to create new things, but it's a lot easier. So this is how we're going to evolve. And here's the metaphor for this. So this is a cell, some cell, I don't remember what, and we've got bacteria here. Okay, this is Legionella, bacteria that are living inside the cell. Okay, and they're going to kill it eventually. They're going to reproduce enough, and they're going to kill it. All right. Any biologists know what that is? Can you make that out? Guesses? Not the nucleus. So there's the nucleus. What? It's what? It's a mitochondria. Yeah, it's hard to see the detail. So that's a mitochondria. Now, what's a mitochondria? Where did we get mitochondria from? No, before that. The original, way back before we had mothers. They're bacteria. Mitochondria are bacteria. How many people knew that? Now you got to raise your hand or look dumb. Come on. Mitochondria are bacteria that we were incorporated into prototypical cells a long time ago, and they provide energy to the cell. A really interesting relationship. They don't kill the cell, but they're in there. They multiply. And if you ever wondered how come bacteria don't have mitochondria, it's because bacteria are mitochondria. And so we've got here in the same cell, we've got bacteria and we've got mitochondria. But here's the thing that changed my outlook on things. So this is a bacterial DNA. I don't know if it's Legionella. It doesn't matter. It's got its own chromosome, and it replicates the chromosome, and it reproduces, and it uses the chromosome to produce enzymes and proteins, just like any other organism that has a chromosome. Okay, but here's the chromosome of a mitochondrion. All right, it's very simple, and you can use this for genetic family history and all that kind of stuff. But the thing that struck me is, I'm like, how can this be so simple? There's not enough things in there to make everything you need for mitochondria. So I went to read about it to find out why that was. Anybody know the answer? Okay, good. So I wasn't dumb. It's something not commonly known. A lot of the chromosomal functions that were originally in the bacterial genome have been acquired or replaced by the host. So it's been an evolutionary process. So instead of the mitochondria have to making some enzyme, the host cell makes it. And the mitochondria benefits from that and doesn't have to do all that extra work. It lets the host cell do that. So it's been an evolutionary process. These mitochondria can't live freely anymore. They don't have enough, they don't have enough genetic makeup to reproduce or to do all the things they need to do. They're very dependent on their host cell, and vice versa. Our cells can't live without mitochondria. Very tightly intertwined. But it's been an evolutionary process that got the genome from that to this. So this now is my EAV table, my original EAV plus table, and here's the new one. It starts to get simpler as the host, the electronic health record, takes over some of these functions. So this is my idea of the evolution, is this three-step process. And I think we can get there without disruption. We have a black box, it's just a document. Hey, Cerner or Allscripts, can you hold on to this document for me for this patient and give it to me when I need it? Sure, okay, I'll hold it. Let me know when you need it. Are you allowed to see it? Is it the right patient? Here you go. Give it back, store it, whatever. Then we make it something that's accessible and at camel's nose in the tent. And once we, that, why I say camel's nose? If you put a camel's nose in the tent, the camels don't back up. They only go forward. So the camel will just continue until the whole camel is in the tent. All right, that's the metaphor there. And then we do it in a healthy way, as symbiotic relationship. Okay, so we have to shift this paradigm of thinking about tactics versus strategy, about the state of the patient. And we can do this. We're going to need informatics research to develop new models. We're going to have to do it incrementally. We're not going to do it all at once. We're not going to sit down for 20 years, like the psych project or something, and think up, another Texas thing, think up how are we going to represent the patient in some way that we can then compute on. We'll pick out pieces. We don't have to do the whole thing. But we create deeper models and we start to work on those. We need informatics research also to figure out how are we going to get this additional data captured? Where's it going to come from? We can't just ask the clinicians to put in more data. Even if we say, listen, now you have free time because you're not writing those notes, put more data in. It's still too much for the individual clinicians to do. So we have to come up with new ways to do this more effectively. It's going to require not just building systems, but we're going to have to go back and change the educational process. That day where they teach doctors how to write notes in medical school, we got to teach them, what's the computer really doing? What is it it's doing, and here, how do you work with the computer so that it will help you? How do you tell it what you need to tell it so it can do it? That we have to change in medical school, we got to change it in nursing school, and we got to do it in patient school. We've got to teach patients, this isn't about, oh, you have diabetes, you should do this and don't do that. This is about, you are a patient in a health system. Your life depends on you behaving in a certain way so that the health system can help you. Here's how you give a better history. Here's how you keep track of your travel. Here's how you keep track of what the doctor told you when you went to see an outside doctor, so that when you come in, you contribute useful, usable data, and we find ways to capture those data and make them operational. And Larry Weed talked about this in 1968. Get the patients to contribute more data to the record. And then what about all those apps? Okay, have I just, sure, I've done all this stuff, but the apps, those are really hard. It turns out we've been building these apps for decades. Okay, so here's Jing Zheng, who's the student that I brought around on the wards coincidentally, but I took this picture back in 1996 for a talk I gave at the first AMIA Fall Symposium, and those are the SCAMSI proceedings from 1980 to 1995. I was missing a couple of years. I was missing 3 years. Those are SCAMSI proceedings. Those things are full of little 5-page descriptions of apps. Hundreds and hundreds, thousands and thousands of them. And this pile would be taller than she is because that was 20 years ago. And we're still doing the same thing, building all these little apps, writing 5-page papers, and publishing them. And then somebody goes, oh, that was cool. And then it dies. The project dies because it couldn't get the data it needed. It couldn't be incorporated in a real system. They were good ideas. They got us tenure. They got us grants. Maybe we, developed something else from that. But there's lots of ideas in there. And now those things could actually appear. So we've been building the apps for a long time. All right, so then you can go back and think about these questions and think about, now, what is that black box going to have to look like? What do I have to have in there to build that? And then once I have that, I go, how do I get that data? Where is that going to come from? And I don't have to do the whole thing at once. I just have to do the pieces that I need for my app. Okay, you know what? I want a knowledge base of current hotspots for infectious disease. I can pull that out of the CDC. I can write a program that'll build my knowledge base automatically. So now all I need to do is have a patient point on a map where they went. Oh, I was here, I was here, I was here, and now I could take that information, or maybe I use their cell phone, or their email, where their email came from, or who knows what. I read their tweets, and I figure out where they were, and I match that up with my knowledge base, and now I have travel history that is usable for looking for possible infectious diseases. So pick any of these things. They're all PhD level projects, and we figure out how do we build that, how do we reverse engineer that black box. Okay, so the take-home messages. First of all, it's about representing the states of the patient in computable ways and strategies also in computable ways so the computer knows what the heck's going on. We define that black box, figure out what's inside, and then we reverse engineer it to get to the point of the data acquisition. Oh, it's very nice to have this in there, but it's pie in the sky. No, we just have to solve a problem. It's an informatics problem. That's what we informaticians do, is we figure out new ways to solve that kind of problem. We don't just write a computer program and say, hey, doc, you got to fill out this form. Okay, that's what the IT folks do, but informaticians figure out a different way to solve that problem. And we find a way to evolve without killing the host. We find a way to bring this into and take advantage of all the things that EHRs do really well, and without having to re-engineer those and start from scratch. And then we have to teach the paradigm to all the players, the patients, the physicians, the families. Everybody that's going to contribute data and interact with the system has to know how it works. And it shouldn't just be some neural network that's, well, we don't know how it works, but it's going to tell you something. We tell it, this is why it's doing this, and if you do your part, it's going to do this part, and you'll be able to understand. It's like video games, Kids, if you play video games, the characters and the things in the video games behave in a certain way, and you understand that. You understand what to expect, and if I shoot at this, it's going to do that. If I, buy this, it's going to strengthen this. Whatever it is in the video game, you understand the underlying paradigms. It's not a mystery. You wouldn't be able to play the game otherwise. But when you understand it, then you interact with it and you succeed. And I think that's my last, that was my last one. So thank you for your attention. Thank you for being guinea pigs for this talk. I appreciate feedback, but right now I'll take questions. Yeah, Todd.
So, I agree with states and strategies would be good. Just looking at sepsis resuscitation, we have pretty much the process is a clear process. We have no idea when time zero is, no one indicates that. We have no way of tracking that process in time. Doing this, I do modeling, really requires an extremely expressive language. So just forgetting about how we do the data entry, it has to be very expressive language. And I just wanted to get your feedback. You see, there's a lot of input in there. It's great. Ontologies are great. There's a lot of them. Alan Rector's written that the most expressive language we have is natural language, right? And that any ontology that's sufficiently expressive is probably computationally tractable given our current AI technology, right? And if it is computationally tractable, then it's not going to be expressive. He's written about that in terms of clinical terminology.
Well, I disagree. I disagree with him.
Well, let me add one line to Todd's question.
Yeah.
How much? So in addition to the language and the expressing all of this stuff, how much would AI have to advance to make this a reality?
All right. So the question for those that couldn't hear is is there a language that's expressive enough to do what I'm proposing to do that's computationally tractable? And is AI, and Elmer's edition was AI, how much would AI have to advance to address this? I think that we can, if we divide and conquer this problem into specific problem-oriented tasks, we can get pretty far along. Now, will the whole process break down when we have more than one problem, multiple problems and the systems are fighting over it? I think that's another question we'll have to address. But I think that we can find expressive languages that will be computationally tractable if we break this down into sort of the kinds of things we know. I mean, we think about, all right, I want to treat a patient with a drug. There are a bunch of rules that I have to follow, and there are knowledge bases where I could express those rules. Now, there's always something that, we didn't put, so what was Oncosin, gave you rules for how to treat patients with cancer. This goes way back, and people were overriding the rules. Why were they overriding the rules? Because a patient was going to a wedding. Patient's going to a wedding. What does that have to do with anything? Well, the drugs they're giving cause nausea. So the patient would come in and go, I don't want to take this drug today because I'm going to a wedding tomorrow, so give it to me next week after the wedding's over because I don't want to throw up at the wedding. And so it didn't have that model. And so there's always going to be those kinds of things, and we have to recognize that there's going to be places where humans will have to override it, but I think there's a lot we can do because we do so poorly now. I mean, my mom was just in the hospital, and for crying out loud, they gave her magnesium citrate, which is a laxative, and I think they gave it to her because probably her magnesium was like 0.8 instead of 0.9 or something stupid, and they said, oh, we'll give her mag citrate. That's a good idea. Not for a woman that's had half her colon removed, and she's like pooping her brains out. You're all done, right? She's pooping her brains out, and she's called. I said, how you doing, Mom? She goes, well, I'm pooping my brains out. I go, what did they put you on? Well, they gave me this thing, and it begins with a C, and like, read me the bottom. She goes, citrate. I'm like, citrate? Is it magnesium citrate? Yeah, that's... So, I have to call a doctor and go, she's missing half her colon. Oh, I didn't know that. I'm a cardiologist. What do I know? I think we can do better. I think we can do better than that, There's the story about the two people in a tent, and a bear comes into the campsite, and one guy, they jump up, and, they got to get away, and one guy starts putting on his sneakers, and the guy goes, what are you putting your sneakers on for? That's not going to help you outrun the bear. He goes, I don't have to outrun the bear. Okay, we don't have to do a lot to do way better than we're doing now. So
Maintain active problems.
that's right. We can't maintain active problems. So let's study that problem and figure out how we do that. Let's figure out how we represent the problem in a way that the computer can go, this is a past problem, or this is a chronic problem that's not really a problem right now, but will become a problem if certain things happen, like the patient has a positive PPD. When I was at Columbia and I was writing notes, I always wrote that the patient had a positive PPD. That was always in my problem list. Manually writing that note when I was paper notes, because I knew one of these days, one of these patients was going to come in and somebody was going to put them on steroids. And I wanted that positive PPD to be on the problem list so that they would know that that patient had that problem. That was pretty tedious, right? Most people were looking at it, why the heck is he putting this on this list? Or, you know, status post-nephrectomy. You know, okay, you had your kidney out, big deal. You've recovered from the surgery, you went home, you can live fine with one kidney until somebody wants to take out your other kidney, you know, or they want to give you genomycin or, you know, some other thing that you shouldn't give people that only have one kidney. So that there are things in the background. How do we represent that so it's not in your face every time? You're not overwhelmed with all this little detail that's not relevant. But when I go to order mag citrate, it goes, this patient is status post a procedure that, you know, maybe wouldn't be such a good idea. And now, of course, the cardiologist doesn't need to know she had it wasn't taken out for cancer. She had, you know, another problem, and that problem subsided. But now she's left with the complications of the surgery. The cardiologist doesn't normally need to think about it until he's ordering something that he does need to worry about. So how do we model that in some way? And I think we can do that. I don't think that's intractable. And if we do it 99% of the time, or 95% of the time, or even 80% of the time, we're doing way better than we were now. So, and as far as AI, I think the sky's the limit, but I think we can do a lot with what we have today. I think that the reasoning, as I said, the kind of reasoning that we need to do is not so sophisticated. It's just that the human beings don't have the whole picture, and they don't have the perfect memory that the computer can have, and so we can't sort of process all these little details and remember them. But AI, I think, is certainly at that point now. I mean, we've got Siri, you know, talking to us and giving us advice and figuring out what we're interested in. I think we could do at least that well. Yeah.
In the Weeds example, that's at Emory, not Baylor.
Oh, I'm sorry, you're right, Emory.
In
Yep.
his example, he was very keen on capturing the patient's story because as an internist, he felt that there's layering way that if you listen to the patient long enough, he's going to tell you what they have. We've lost a lot of that today, but I was wondering if you can comment on, do you think eventually a clinician will be more of a reconciliatory type behavior, whereas, because that's one of the things we always do. We're always reconciling what we know, what we need, and what we need to document from a clinical reasoning standpoint. So do you feel that the data entry will somehow lessen and will become more of a reconciliatory behavior for us clinically? Like how you know.
Okay, so the question in the back is, are we going to move to the point where the clinicians are doing less data collection and more reconciliation of data that's collected in other places? I think absolutely, and we're doing it now. So when I was a house officer, I did gram stains. And I did stains for acid-fast bacteria in the middle of the night. Now I'm not allowed to do that because I'm not a certified lab tech. Somebody else does that for me. When I was in training, and you know, the EKG machine didn't have the interpretation on it. It just was a squiggly line, 12 squiggly lines, and you had to figure out what was going on. Now it's got the interpretation. So we move a lot of that stuff over. You know, reading your own X-ray. Now we have radiologists to read the X-ray. I mean, so we're moving in that direction all the time, to the point where, you know what, I can't read ultrasounds anymore. I kind of gave up on ultrasounds a long time ago, and I go, I'm just going to read the report. And yeah, it'd be nice, and somebody can show me, see, there's the gallbladder, and there's the baby. I'm like, okay, whatever. But when I'm, you know, mostly I trust somebody else to do that interpretation. And I figure out how to take those higher level concepts and do something with that. The problem is that right now, the system doesn't have those higher level concepts modeled in a way that it can help me to you know, and those are the state variables that we need to get at. But I think we've always been moving in this direction. It's just going to move faster. The genetics stuff, you know, they're going to show us a marker. You're not going to go, oh my gosh, she's got lysine instead of arginine there. That means that this protein is going to look like this, and that means that the oxygen dissociation is going to look like that. And you know, we can't reason from first principles anymore. So we just need the system to go, that variant, don't give that drug. Don't worry about why. You know, we've figured out. And I think that's going to, you know, we're just always moving. It's just going to happen faster.
So it's 1 o'clock. I'm sure there are other questions. I have 20. So let's thank Dr. Savino.
Okay, thank you. Oh, good. Thank you.
Don't forget to get rid of this so that you're not recorded with bad stuff.
That's right.
We're swearing at us.